Hi, good day to you. This is me again. I wasn't planning to make this video. I got a little distracted from my main project this past few days because I saw this and it suddenly dawned on me that I need some vegetation in my game too. And it wouldn't be lush green because of my post-apocalyptic theme, but I still needed something to invigorate the atmosphere. Or so I thought, because it can't just all be, barren concrete wasteland all the time. Now in Godot 3 I used to use the scatter plugin, which hasn't been upgraded to Godot 4 yet, so I decided to try and create my own, which I did, and that's why we're doing this video. It's definitely not as feature-packed as scatter, but it does let you do quite a bit of stuff. I'll show you what you can do with it, but more importantly, I'll show you how it's done so that you can build on it yourself if you want, and add more features to it and what have you. So basically it's a script that you should attach to a multi-mesh instance node. I have a simple triangle mesh in the mesh property here. This is going to be my blade of grass. You will also need a terrain mesh with collision. I have this very simple terrain chunk which I made in Blender. You need a center node. This could be any type of 3D node. I'm using position 3D, but it could be anything that inherits from node 3D. And optionally, a player node. This one would interact with the multi-mesh. I'll show you what I mean in a second. So if I select the multi-mesh, let's see what parameters we have. We have the path to the character node, and again, this is optional. We have the clump center, this is not optional. You have to tell the script where the origin of the clump is. So if I grab the center node and move it around, you'll see that our lovely little clump is dutifully following the center, and it's snapping nicely to the terrain underneath. Next one down is the clump radius. Self-explanatory, just increase that and see the clump grow. Clump angulate is for changing the shape of the clump towards a rectangle. Thickness is what it says it is, how thick your clump is going to be. And if you enable meadowing, you can poke a hole inside the clumps like a meadow, and you can control the radius of that meadow. You can control the width and height of the blades, of course. The position and rotation of each blade is randomized by default. You can switch it off if you have a use case for it. Otherwise, keep it on, and here is the aggregated amount of randomization. So if you bump it up to the max, it will kind of look like seaweed, very disheveled. But for wild grass, 40 to 50 is usually the sweet spot. The blades are using a shader material. I grabbed one off of godotshaders.com, but I added a lot more features to it, notably subsurface scattering, which can make quite a bit of difference, especially for vegetation. And you can also mix albedo with the color ramp and some other things. The other cool thing about the shader is that it makes the blades interact with the character node. So you can see here when I'm moving through the grass, the blades get pushed away, which really adds to the realism. So let's go ahead and look at the script. By the way, I'm not going to explain every line. Some of this is just obvious. So first of all, you see here at the top, I'm using the tool keyword to have the script run in the editor, and these get and set are the new way of achieving what setGet would do in Godot 3. SetGet is gone from Godot 4, and here's a new syntax. Get gets the current value of this variable from the inspector, and set sets that value for the variable and runs a function that you specify. So in my case, this is going to be the scatter function because that's where I keep my scattering logic. So these are all the export variables I've just showed you in the inspector. In process, I'm just checking for the clump center position versus the previous tick, and run the scatter function if the center node has moved. I'm also updating the character path in the shader. If you recall, the shader needs to know the character's position so it knows where to bend the blades away from the player. And then inside of the scatter function, theta and increase are needed for the sine and cosine math. Basically, when I'm looping through the multi-mesh instance count, theta gets bumped by increase each time, and combined with the sine and cosine of itself, multiplied by the line segment from the center of the clump to the radius setting, it distributes the instances in a circular fashion. And if you increase theta on one of these axes, x or z, which you can see I'm doing here, multiplying it by the angulation parameter, it will distribute the blades in a more rectangular fashion. Begin pause is basically a global position from where each instance is going to shoot a ray in order to detect the terrain mesh. And I have to get the target position so that I can grab its y coordinates and use it to determine the y position of this instance. instance, this blade. So to get this, I'm going to cast a ray from the start position to 1,000 units below it. So it's going to be a vertical ray. I know the start and end positions of the ray, but to cast it, I have to first get the space state of my current world, and I have to create a ray query in the physics engine. And then I have to tell it where to cast from and to, and optionally define the collision mask. This number here is converted from a binary to a decimal using an online converter. I'm using the number 7 because 7 ignores the collision layer. So the ray will ignore everything that's on the first collision layer. And the reason I'm doing that is because my terrain mesh is on layer 2 and the player is on layer 1. So I want to ignore layer 1, otherwise the grass would also grow on the player. That's not what I want. And the function returns the raycast collision point, which is the point on the mesh where I want to put the blade. So then I declare a transform variable, and it's going to be a transform 3D that's rotated and scaled by the parameters in the inspector that you saw before. So horizontal rotation, vertical rotation, width and height, including randomness, of course. And then the origin of each blade will be determined by clump radius horizontally and the raycast collision point vertically. So that's where it will spawn, and we will apply the rotation and scaling to it by setting its transform. That's it. That's how it works. So I put this script in my game to test it, and here's the result. Nothing to see here, just a demon-possessed, half corpse, half machine, strolling peacefully through a field of rye towards a soothing sunset. Like and subscribe, and I will see you on the other side. Peace.